All right, I'm adding on this little news and update segment. I meant to do this initially as part of my standard format, but I forgot, so I'm adding it in after the fact. This lets me just remind everyone that there have been several changes that I've been sending emails about with regard to how we're going to be handling problem sets, the online format, and exams. I think most of these elements have been detailed in two documents that are on Canvas now. That's general updates for 2312 online and Gradescope submission guide that's found within the handouts and files sections of Canvas. Friendly reminder, problem set 4 is due on Wednesday before class time to Gradescope. Getting it in earlier in the day as the standard submission time will help with the TAs who will be trying to grade these quickly on Wednesday and Thursday so we can get them back to you on Friday to kind of go over some of the problem set then if needed. The last class, which was lecture 25, we talked about some new methods to reduce different types of functional groups. This led to synthesis of amines from reduction of amides and nitriles. In order to do this, we need to use a strong reducing agent like lithium aluminum hydride. So this is a distinction for nitriles where they go to a primary amine rather than an aldehyde that you'd get with dibol. We also saw that we could make ketones by the addition of Grignards to nitriles, followed by acidic workup. In the last section, we talked about carbonic acid derivatives. So these are a higher oxidation state than carboxylic acid derivatives. They include things like isocyanates, carbamates, ureas, and carbonates. There's a number of addition reactions to isocyanates that'll give us things like carbamates, ureas, and carbonates. Additionally, we can, the carbonates would be synthesized from additions to phosgene. And we talked about how you can make isocyanates as an intermediate or as a product when you are adding amines to isocyanates if you only add one equivalent. In the last section, I'll put a star by this. This was not covered in the lecture in class. Maybe it's just a big blob. It was only on the video lecture, so you haven't seen that. That might be of interest to check out. That'll be needed to do a problem on problem set 4. And the last element I wanted to mention is sort of something in between in terms of reactivity. We talked about how acid chlorides could be reduced to sodium borohydride in class because these are much more reactive than any other carboxylic acid derivative. But something else I want to mention can also react with sodium borohydride is anhydrides. So even though they look a bit like an ester on one half of the molecule, the other half you can kind of view as being an electron withdrawing group or a leaving group. So this changes the amount of resonance that one oxygen can share between the two carbonyls, and this makes each of these individual carbonyls more electrophilic. So this can react with things like sodium borohydride. It'll have reactivity more similar to something like an aldehyde or a ketone. And along the way, we see that we can do our normal addition to give us an intermediate alkoxide. This is able to then fragment to kick out a carboxylate leaving group to make an aldehyde, and the aldehyde can be further reduced to go to a primary alcohol after workup. And similarly, this cannot reduce any further because it's just like a carboxylic acid. You cannot reduce carboxylic acids with sodium borohydride. So this might be of additional interest for problem set 4 when you're looking at predicting the products section.